Theobromine and Cacao: Prehistoric Evidence of Chocolate in Utah by Glenna Nielsen Grimm and Riley Rothy. Chemistry 2320, University of Utah. Theobromine has no bromine in the molecular formula. It derives its name from the plant from which it was first identified, Theobroma cacao. Theobromine was first discovered in 1841 in cacao beans by Alexander Voskresensky. Theobromine was first synthesized from xanthine by Hermann Emil Fischer in 1882, and in 1902 he was the Nobel Prize winner in chemistry. It is classified as a xanthine alkaloid and is very similar to theophylline and caffeine. All three compounds are found in cacao, or chocolate. Theobromine is known to be poisonous to dogs, cats, American black bears, rabbits, and probably birds. There are several plants that contain theobromine, as it is the primary alkaloid found in cocoa and chocolate, which both come from the cacao bean. Some of the main plants it is found in include kola nut, guarana berry, yerba mate, and tea plant. Some of the characteristics of theobromine include: it is slightly water-soluble, it is crystalline bitter powder, it's an isomer of theophylline, a paraxanthine, and categorized as a dimethylxanthine. It is white or colorless, however commercial samples can be slightly yellow. Affects the human nervous system similar to caffeine, but in a lesser role. It is also known to be a myocardial stimulant, vasodilator, thus it reduces blood pressure, and it also reduces coughing and is helpful in treating asthma. The biosynthesis of theobromine. It is a purine alkaloid derived from xanthocene, a nucleoside. Cleavage of the ribose and N-methylation yields 7-methylxanthocene. 7-methylxanthocene in turn is the precursor to theobromine, which in turn is the precursor to caffeine. Alright, here we have the synthesis of theobromine, which was created by Emil Fischer back in the early 19th century. The reaction begins using 3,7-dimethyluric acid, and that compound is reacted with PCl5 and POCl3, undergoing a chlorination to cleave this carbonyl and form a carbon-chlorine bond as well as an alkene between the carbon and the nitrogen. In the next step of the reaction, this compound reacts with NH2 to cleave the carbon-chlorine bond, forming a carbon-NH2 bond for compound 3. And the next step, compound 3 reacts with POCl3 a second time, undergoing chlorination to cleave this double bond, forming a carbon-chlorine and a new alkene between this carbon and this nitrogen.
So we start here with an imine, which is the first time we have this double bond forming the class of imines. And then through an SN1 heated reaction, the chlorine leaves, then we get a carbon hydrogen there. And then we have a nitration where this carbon bond is reformed, the carbonyl is reformed, and the nitrogen is hydrated to give us theobromine, which is our product.
Theobroma cacao, or food of the gods. The name of the tree actually means food of the gods, which is Latin theo and broma. Cacao derives from the Zoque Maya word for the drink and the bean, cacao. The Maya word for cacao was cacawa, phonetically spelled out, ka, and wa, with many cylindrical or round white jars that had the glyph spelled out on the vessel, naming it as a certain type of cacawa drink. Chocolate comes from the Aztec word cacahuatl. Cacao was generally consumed as a drink in prehistoric times. The residue of the drink was trapped in the fabric of some of the ceramic vessels. Residue was extracted in the laboratory, and then the test was for biomarkers of cacao, which are theobromine, caffeine, and theophylline, and ursolic acid was also added as a biomarker for Ilex vomitoria. Tests were made on different vessel types, and it was confirmed that mugs, corrugated jars, and painted bowls all had residues of the biomarkers. Unwashed mugs were also tested in a different procedure, and we had both positive and negative results. Positive for theobromine, positive for ursolic acid in some vessels, negative for theobromine and positive for ursolic acids in some of the vessels, positive theobromine and negative in ursolic acid, which means that we had 2 different caffeinated drinks being drunk in Montezuma Village between 1100 and 1250 AD. So the implications of cacao in prehistoric Utah. Theobroma cacao L can only grow in hot, humid areas as an understory plant. It's pollinated by small, tiny flies. It cannot grow naturally in dry, arid climates. It is restricted to regions close to the equator, no further north or south than 20 degrees. It derives from the upper Amazon, the Orinoco region of South America. No native plants containing theobromine, caffeine, and theophylline grow in the southwest or Great Basin regions of the United States. Ilex vomitoria, which is native to the southeastern part of U.S., is the only other candidate and is not native to Utah or the southwest. So the positive results of the residue test for theobromine and caffeine in pottery separately dated to periods between 750 and 1250 AD suggest trade interactions with prehistoric groups in southern Mexico or Central America. Fruit or non-roasted beans would not have made the long journey. It is suggested that roasted beans or resulting powders were transported north. The results support the growing evidence of continual interaction of Southwest prehistoric peoples with cultures in North and Central Mexico, at least from 750 on.